First, I'll show you the simplest way to convert a multi-page TIFF file to a multi-page PDF file. Here is my TIFF file. As you can see, it's 4 pages. Now let's open Visual Studio 2010. We'll create a new Windows Forms application. Next, I'll add the LEADTOOLS references that we need. The LEADTOOLS DLL is the core DLL that holds the images in memory. The Codex DLL contains all the functions for loading and saving files. The Fax DLL contains the code for supporting CCITT compression. The TIFF DLL allows us to support TIFF files. The PDF DLL allows us to support PDF files. The next DLL is not a .NET DLL, so you must add it as an existing item. The PDF Engine DLL contains all the fonts and other information necessary for loading PDF files. You'll want to alter its copy property so that the compiler copies it to the EXEs directory. I'm going to start off by keeping this as simple as possible. In the form load event, we'll simply load all the pages of the TIFF file and save them as a PDF. First, I'll specify the location of my multi-page TIFF file. Next, I'll create our raster codex object. Use this object to load any of the file formats we support. Next, I'll create the raster image object. This object will hold all the pages of the TIFF file in memory. By calling load, we'll load all the pages into memory. And finally, we'll save all the pages to disk as a PDF file. Now, you can see we have a prefix RAS in front of PDF. This is telling you that the PDF file we're about to save will be a raster-based PDF, meaning the document in the PDF will be saved as an image. You can see we support compressing the image within the PDF as well. For this file, let's select the same compression as the TIFF, CCITT Group 4. I'll add one more piece of code to open the file once it's created. Now we'll run this code. Here is the file in Adobe Reader, and as you can see, we have now converted the multi-page TIFF file into a multi-page PDF. Now let's look at some of the options LEADTOOLS provides when saving and loading a raster-based PDF file. In the raster codex object, go to Options, then PDF, then Save. Now I'm not going to go over all of these, but as you can see, we have many options you can enable or disable based on whether the document is protected. You can protect these options by entering a user or owner password. You can specify the version of the PDF you'd like for LEADTOOLS to save as well. Now let's look at the load options. Backtrack to PDF, then select Load. When loading a PDF, you can specify the bit depth to load the file, or leave it at the default value of 0 to let LEADTOOLS figure out the best bit depth to load the PDF with. If the file is protected, you can specify the password here as well. We have additional options you can use in loading a PDF found in the Raster Codex Options Rasterized Document Load. These options let you specify margins, page width, page height, and resolution. Prior to loading the file, you can access information about the file using one or both of the following methods. The Raster Codex Get Information function allows you to get information about any of the formats we support. One of the features of this function is to get a count of the total pages in the file. Because PDF files contain both vector and image objects, they do not contain a good description of the raster image inside them. However, if LEAD created the file, we can extract more information about the image. The raster codex get raster PDF info function will be able to find out additional information about the image in the PDF. It will tell you whether LEAD created the file or not. If we did create the file, you can use the rest of the information found in the returned class. Typically, you would use the bit depth and resolution information for loading the PDF file. You would place this information in the PDF load options I mentioned earlier. Up to here, we have discussed how LEADTOOLS handles raster-based PDF files. Raster-based PDF files are PDF files that only contain image data. They cannot be searched, annotated, or contain any hyperlinks. For a lot of people, this is all that is needed, but for others, they may need more functionality. For instance, let's say you want to build an Adobe Reader type of application, where you can search the text in the document, click on links that take you to different places in the document, or to a web page. With our PDF document and PDF file classes, you can build such an application. The PDF document object gives you a read-only parsing of the file. The PDF file object allows you to make modifications to the file. Let's see some of these features in code. Using the same application, we'll remove some of the old code. Let's create a PDF document object. However, before we create this object, we must determine if the file is encrypted or not. To do this, we'll use the static function isEncrypted from the PDF file class. If the file is encrypted, you will need to obtain the password to the file. You can do this by displaying a dialog to the user, by retrieving it from a database, or by whatever means your workflow requires. You can then create the PDF document object by passing in the file name and the password. If an incorrect password is provided, or if no password is provided, we will throw an exception stating this. If a password is not required, you simply need the path to the file to create the PDF document object. I'll now change the file name to a PDF file. This file will be encrypted. We'll put a breakpoint here and run the code. And you'll see that we do determine the file is encrypted and create a PDF document object. The PDF document pages collection is automatically populated when a new PDF document object is created. The total number of pages in the document can be found in the PDF document pages count property. Each item in the pages collection corresponds to a page in the PDF document. So item at index 0 contains the properties of page 1, item at index 1 contains the properties of page 2, and so on. The PDF document constructors will always populate the collection in the correct order from first to last page. Each PDF document page contains two rectangular areas, the media box and the crop box. The PDF document page class will load and store these values in its media box and crop box properties. The PDF document page class contains the width and height of the page in PDF units, which is read from the PDF file directly using the PDF crop box. PDF units are in 1/72 of an inch. The size of each page in PDF units will be automatically set in the width and height properties. The size of each page in inches will be set in the width inches and height inches properties. Both of these values will be fixed values. The size of the page in pixels depends on the value that was set in the PDF document resolution property. This value can be changed by the user at any time, so the pixel size of the page changes accordingly. To get the size of the page in pixels, using the current resolution, use the width pixels and height pixels properties. Now let's load the sample PDF LEAD ships with the toolkit in order to look at some additional features. You can locate the PDF file by browsing to your Documents folder, then clicking on the shortcut to our images. We'll copy the path and replace it here in our code. The name of the file is LEADTOOLS PDF. You can populate each PDF document page object with various PDF native objects found in the PDF file. Here I'll obtain an instance of the PDF document page for the first page of the file. To populate this instance with the native PDF objects, call the function Parse Pages. Let's debug this code now. When you first create a PDF document object, the collection's fonts, hyperlinks, and objects will have a value of null. When you call Parse Pages, each collection will be populated with the objects found in the file. The collections that are populated will depend on the options you pass into the function Parse Pages. If no objects are found in the file, the collections will contain an empty list. Let's call the Parse Pages function with the option All Ignore White Spaces. This means to parse all options but not to include any spaces in the results. In the fonts collection, you can see we have two fonts that were found in the file, Arial and Arial Bold. In the hyperlinks collection, we have one hyperlink. The URL can be found here in the hyperlink property. You can use this data to launch the default browser with the link. The objects collection has many items. Each item could be a character, line, or rectangle found in the document. You can check the object type property to see what type of object the item is. If the item is a character, you can check the text properties to see more information about the character. You can find out the character's font width and height, as well as which index in the font collection it is using. You can also see if the character is the last character in the word or line. Aside from these three collections, you can also use the PDF document page class to convert a point or rectangle between inches, pixels, and PDF units. Use the convert_rect or convert_point to perform the conversion. Just as in the previous collections, the PDF document bookmarks collection and internal links collection are set to null initially. When you call the parse document structure function, each collection can be populated. If no information is found in the file, then each collection will only contain an empty list. Let's debug the code to see what information is found in this PDF file. As you can see, the two collections are null initially. Now we call the function, and you can see they are populated. In the bookmarks collection, you have access to each bookmark that is found in the file. The bookmark item contains the text and text style of the bookmark, the hierarchical level, as well as the page number, zoom and position of the target page. We also describe how the target page should be fit on the display. In the internal links collection are all the links between pages within the PDF document. We give you a description of the link itself, including color, dash length, and width of the border for the link, the bounds and page number of the link, as well as the page number, zoom, and position of the target page. We also describe how the target page should be fit on the display. The resolution property is not only used in calculating the image's dimensions in pixels, but also used in generating a raster version of the PDF with the getPageImage function and the getThumbnail function. Here I'll use these two functions to generate an image from the PDF's first page. Let's first create a thumbnail. You can specify the page number as well as the width and height for the thumbnail. For the getPageImage function, you simply need to specify the page number. For both of these functions, you can also pass in your own raster codecs class. The PDF document properties property allows you to obtain the metadata for the PDF from the header of the file, such as author, title, subject, and keywords. In the PDF document class, you can only read these properties from the PDF document. Using the PDF file class, you will be able to alter these values and write them back to the PDF file. To determine the file type or the version of this PDF file, use the PDF document file type property. This could be set to encapsulated PostScript, PostScript unknown, or any of the PDF versions we support, 1.0 to 1.7. Using the PDF file class, you will be able to change the version number of this PDF file to any PDF file version LEAD supports. And last but not least, for the PDF document object, we give you access to the file name and password passed into the constructor of the PDF document object. Next, I'm going to talk about our PDF file class. You've seen me use its isEncrypted function and heard of some of the features it offers. Now I'm going to show you all the features it contains. First, I'll show you how to create an instance of the class. The PDF file object has the same two constructors that the PDF document class has. So I can simply replace the PDF document with PDF file here in our code, and it should all compile and work correctly. Alternatively, the PDF file class has a constructor with no arguments. If you use this constructor, be sure to set the file name property and also the password property if the PDF is encrypted before calling the next function. You can check what file type has been selected using the static PDF file function called getPDFFileType. This will return a constant identifying the file as PDF with the version number, or identifying the file as PostScript or encapsulated PostScript, or return the constant unknown. You also pass a Boolean value specifying for the function to only return a PDF type or unknown if you do not wish to support PostScript files. After you have an instance of the PDF file class with the file name and/or password set, you can then call the load function. This will populate the document properties property and the pages collection. However, keep in mind that the load function only works with PDF files. If you have specified an encapsulated PostScript or a PostScript file, the load function will throw an exception with these file types. Once you call the load function, the document properties property will be populated with the PDF file's metadata. such as author, keywords, subject, and title. You can modify this data or replace the class instance with an instance of your own using the setDocumentProperties function. The PDF file class will use this data whenever it creates or updates a PDF file. The pages collection is also updated once load is called. The total number of pages in the document can be found in the pages count property. Each item in the pages collection corresponds to a page in the PDF document. So item at index 0 contains the properties of page 1. Item at index 1 contains the properties of page 2, and so on. The load function will always populate the collection in the correct order from first to last page. Each item in the pages collection is an instance of the structure PDF file page. It contains the PDF file page's dimension and page number. The dimensions of the page are in inches. By default, the security options property will always be null initially. If you would like to encrypt the PDF file, you will need to create a new instance of the PDF security options class, populate it, and assign it to the security options property. Our PDF security options class lets you protect features such as annotations, copy, edit, and printing with an owner password. You can also supply a user password to protect the document from being opened. The PDF file class will use these settings whenever it creates or updates a PDF file. With the compatibility level property, you can specify which version of PDF you wish to have written to disk. Possible values are default, which is 1.5, or 1.2 to 1.5, and also PDFA. You can use this property with any function from the PDF file class to create or update a PDF file, except for the convert to PDFA function. A faster way to obtain the total number of pages in the PDF file is to use the PDF file function getPageCount. This method is faster because it does not parse each page of the PDF file or read the PDF file metadata as the load function does. The rest of the functions all have to do with creating or modifying a PDF file. I have some sample files we can use to see each of these functions in action. We'll start first with the convert function. But before we use it, let's check the original file's PDF version. Here we can see it's 1.4. Let's now load the file and alter its document properties. Let's change the author and the subject. And we can change the version of the file. Let's update this to the latest we support, which is version 1.5. Now we can call convert. We'll start with the first page and specify -1 for the last, meaning to process all of the pages. We can pass null to update the original file, or we can specify a new file name to create a new file. Let's update the original file by passing null. I'll add some code to launch Adobe Reader once the file is created. I also need to update the path to the file. and the file name. Now let's run this code to see the results. We'll check the document properties and see our updates and the version. Now, if we want to convert this same file to a PDFA file, we can use the Convert to PDFA function. We can leave the rest of the code the same, as this function will only use what it needs and ignores the rest. Let's run this code. You can see that the PDF version was ignored as we stated earlier it would be. However, you can see at the top Adobe recognizes this as a PDFA document. The next function we'll take a look at is the Delete Pages function. I'll update my file path to point to the new multi-paged PDF file. Let's also take a look at the file. Each page is numbered with a page number. We'll check the page count using the getPageCount function. The Delete Pages function is very straightforward. Simply pass in a range of page numbers you would like to have removed from the file. Let's remove the pages 3 through 8. Again, you specify for the resulting PDF to be the original file by passing null, or you can specify a new file name. And let's check the page count after we have removed the pages. Let's debug this code. You can see initially the page count is 10, and now the page count is 4. Looking at the PDF, you can see pages 3 through 8 were removed. The next function, Extract Pages, is very similar to the Delete Pages function, except instead of removing the specified range of pages, it leaves behind the specified range of pages. Let's replace Delete Pages with Extract Pages to see the difference. Here's the original file, so you can see it also has 10 pages. Let's run this code. The initial page count is 10. After we extract the pages, it is 6. And you can see only the pages 3 through 8 remain. With the function Insert Pages From, you can insert pages from an existing PDF file into the file associated with the PDF file object. The first thing I'll need to do is change the file name we use with this project. This will be the original file. Next, I'll add another file name so we can insert it into our original file. The first parameter specifies where in the original file you want the insertion to begin. The next parameter is a PDF file object. Be sure to include the password if the file is encrypted. And finally, specify the range of pages you would like to have inserted into the original file. Let's run the code. Initially, we have 10 pages, and now we have 16. We can view the resulting PDF and see that the pages were inserted. The merge with function has two overloads. One which takes an array of strings containing the file names of the PDF files you want to merge with the file associated with the calling PDF file object. The other overload takes an array of PDF file objects which may have both properties file name and password set. This is to allow you to merge PDF files which are encrypted. To illustrate this, I will merge 3 PDF files together. The 3 files are not encrypted, so we'll use the overload requiring a string array. And we'll specify null to save this to the original document. Let's run the code. The original file has 10 pages. The resulting file has 30. We can see that the 2 other files have now been merged with the original file. The replace pages from function will merge a range of pages from one PDF file into the file associated with the PDF file class, starting at a particular page number. For this function, I'll only need 2 PDF files. The first parameter specifies where in the original file you want the insertion to begin. Let's choose page 7. The next parameter is a PDF file object. Be sure to include the password if the file is encrypted. And finally, specify the range of pages you would like to have placed into the original file. Let's run the code. Initially, the file has 10 pages. Afterwards, the file has 12. Browsing through, you can see we replaced pages 7 through 10 of the original file with pages 5 through 10 from the reference file. The linearize function will reorganize the PDF file in such a way that its first page can be viewed in a web browser while the rest of the file is downloading from a web server. You can specify a new file name or pass null for the same file to be updated. The write bookmarks function will write a list of bookmarks out to the specified file. You can either create the bookmarks from scratch, or you can read the bookmarks from the PDF file using the parse document structure function from the PDF document class. You can then update the bookmarks and pass them to the write bookmarks function to update the file. The distill function will create a PDF file from a PostScript file. You can adjust the default options by passing an instance of the PDF distiller options class to the distill function. The PDF distiller options class allows you to adjust the auto-rotate page mode options to all, page by page, or none. You can also adjust the output mode to be one of these options. eBook Optimize, which is similar to Acrobat's eBook setting. Pre-Press Optimize, which is similar to Acrobat's Pre-Press Optimize setting. Print Optimize, which is similar to Acrobat's Print Optimize setting. Screen Optimize, which is similar to Acrobat's Screen Optimize setting. And Default, where the output is intended to be used across a wide variety of uses, possibly at the expense of a larger output file. In the distill function, you also specify the name and path for the PDF file that will be generated.